Hey everybody, we are talking about cylinders today. We are going to find the total and lateral surface area of them, and this is probably, if you do them right and follow what you're asked to do, probably going to be one of the easier shapes to deal with. So again, we're talking about a cylinder. You know what these are: soup cans, Coke cans, soda cans, whatever. And when we unwrap, well, I'm going to unwrap this in a minute, but I'm going to do it with a little magic. So if you look, I'm going to take our solid cylinder here, which you can see this is very, very solid, and I'm going to put it here. Oh, I'm sorry, I got to turn that over. I'm going to put it here in this case, okay? And I'm going to say the magic words, whatever they may be. And now, oh, it's not solid anymore, and I can take it apart. Wow, look at that. I have made this shape look like what it looks like when you unfold it, if you could do that. Okay? Sorry, a little magic. If you caught it, maybe you have to go back and rewind it, but yeah, there was some trickery there. So when we talk about a cylinder and we take away the shapes that it makes, as you see, a cylinder is made up of a rectangle and two circles. Now we talk about the lateral surface area, which is just the area going up. It is just the rectangle part of this. Okay, so this is the lateral surface area, and this would be total. Again, all we're really going to do is fill in the numbers for the formulas and solve them, but this is how this works. So again, one more thing that you do need to know: the height we're going to deal with is going to be this number here, but the other number that we're going to get with the formula is basically, if you look, if I can show you the best way, is the distance around this circle one time. Okay, watch. As I unfold this, you can see that it goes to the ends here. And as I unfold this, this line that goes around the circle is our length of our rectangle for this shape. So that's how those work. So let's look at our formulas on our notes page here. And just like we did with the other shapes that were similar to this, we started off with lateral surface area. So what you want to do is you want to turn over, and we're going to start with lateral surface area, which is this shape here. So we're going to zoom in a little bit so we get started, and we're going to start off our basics. We're doing surface area, but we're doing lateral surface area, LSA. The name of the shape, you all know this is a cylinder, spelled correctly if I did it. The formula for the lateral surface area, well, that's one you're going to have to look up, and it's going to look a little different, but the formula for lateral surface area is 2 pi radius height. So 2 times pi times radius times height. Shape of the base is a circle, and even though we don't really use it much in this formula, the lateral surface area formula, there it is, shaded in. Now, the radius, very important that for the formula we're using radius because that's what it asks us to use. So, the radius, notice it gives us diameter. It tells us the distance all the way across this circle is 20. Well, we have to know the difference between radius and diameter. The diameter is 20, that means the radius is half of that, or 10. And the last thing is the height of the cylinder. Now, even though this line right here is on the bottom of it, we have to imagine that when we're dealing with a cylinder that it's actually sitting on its base, okay? So there's a base down here, or this one. We have to imagine that it's sitting there to find the height correctly. So the 24 is our height, okay? So we're going to put that number in for our height. And then, as it says here, we're going to plug and chug. That just means we're going to put our numbers in where they're supposed to go and solve the formula. So 2 pi radius height. For the notes, we are going to use 3 for pi just to make it easier. So 2 times 3 times 10 times 24. Now, though this might involve a little bit of math, it's just multiplying. You shouldn't have much of a problem with it. So 2 times 3, you can do is 6 times 10 is 60, and 60 times 24 get you a final answer of 1,440, and that's in square meters because our measurement is in meters. And since we're doing area, we always work with square units, whatever the unit might be. So square meters. Okay, let's do another one. Find the lateral surface area. So again, we're doing lateral surface area. The name of the shape is a cylinder. The formula, pretty easy one, 2 pi radius height. Shape of the base we know is a circle, and we're going to shade it in, even though we don't really use it much for the first half of the formula other than finding the radius. So the radius, as you see, we are given that number 3 because that's half the circle, or half the distance across the circle. And then the height, again, we're talking about the height of the cylinder, how tall the actual cylinder is. So that's the line, again, that connects the two bases, and that number is 9. Once again, we're just going to put those numbers in the formula and do some math. We're going to use 3 for pi, so 2 times 3 times the radius, which we found was 3, times the height, which was 9. 2 times 3 is 6, times 3 is 18, and 18 times 9 gives us a final answer of 162. And this one is in square feet. So 162 square feet is the answer to this one. Okay, now we're going to turn over to the other side, and we're going to do total surface area. And we're using totally new shapes this time, so we're doing a totally new problem. So the formula is going to be a little bit different, but for all the other things, we're just going to basically follow the same idea that we've been using before. So now we're doing total surface area. So TSA. The name of the shape is a cylinder. The formula is a little bit longer, but it does start out the way the other one did. 2 pi radius height. But then the back end of it is 2 pi radius squared, which kind of looks like 2 times big B that we used with those other shapes. And the big B in this case is pi times radius squared, because now we're just adding the shape of the two areas of the bases that we found to the lateral surface area that we find at the beginning. So shape of the base is a circle. We're going to shade it in. Radius of the base, because if you look on the formula, we don't really need anything new. We're just going to still use the radius for the second half of the formula. So nothing really new as far as things we have to find. The radius it gives us is 4, and the height again is the line that connects those two bases, which is 6. So we're going to come over here and we're going to write out our formula. 2 pi radius height plus 2 pi radius squared. As we talk about this, please remember the last thing you'll do is this adding of these two answers. But when you do this half of the problem, you got to make sure that the radius squared happens first, because we always follow order of operations. So now we're just going to fill in the numbers we have. 2 times 3 times 4 times 6, 2 times pi times radius times height, plus 2 times 3 for pi times the radius squared, which when I get to that will be 16. So if I want to just do that first, that's totally okay and may help you. Some of you may actually write out for this part 2 times 3 times 4 times 4, which is again totally okay. So I'm going to do the first half of this problem. 2 times 3 is 6, 6 times 4 is 24, and if I did 24 times 6 I would get 144, plus 2 times 3 is 6, times 16 is 96. And when I add those together, I get a total area of 240. So my answer for that one is 240 square centimeters. And again, if for some reason we went back and read the question again and it said find lateral or find the area of the label, and you did this part first and then you realize you did it wrong, well, you actually did find the lateral surface area. That's that number right there, because that's the first half of that formula. Okay? All right, one more example. As you see, we have another cylinder that's laying on its side. Again, this should tell us right here that the height of the cylinder is 18. That number is our height. So if we want to write that number in first, that's a good idea. And actually, we're done with that number. We don't need it anymore. You can cross it off. That way you don't accidentally use it for something else. Again, we're doing total surface area for this. The name of the shape is a cylinder. The formula, 2 pi radius height plus 2 pi radius squared. shape of the base, as these all have been, is a circle. And the radius, and this is just another tricky part, you got to make sure you do, if the line is all the way across, that means that's the diameter, and the formula asks for radius, so we got to find half of that. So the radius for this problem is 6. Again, we're just going to come over here and write out our formula. And as long as we follow it correctly, we should come up with the correct answer. So 2 times 3 for pi times the radius of 6 times the height of 18 plus 2 times the 3 for pi times radius squared, which was 6. And again, since that has to happen first, you might want to just do that right now. 6 squared is 36. Okay? Now we're just filling in, doing the math and getting through all this work here. So 2 times 3 is 6. 6 times 6 is 36. And 36 times 18 gives us an answer of 648. Plus 2 times 3 is 6. 6 times 36, although normally you would do some math to solve that, I'm going to do it for you, is 216. And now all I have to do is add those two numbers together, which gives me an answer of 864. We're dealing with inches, we're talking about area, so it's 864 square inches. So again, if I wrote this shape out, what it would look like, I got a circle here and a circle here. The lateral surface area is this area right here. The total surface area was 216, but that's for both of these circles. So that means this one was 108 and this one was 108. And that's how we basically did all of that. But again, we just used the formula. So there you go, your notes for cylinders. And when you get to class, we will do some more work with these and you'll be experts at these too. All right, we'll see you later.